my dear students. Today's lecture is about the 8051 hardware architecture. The main focus for this lecture is 8051 pinouts, I/O ports, dedicated bus control signals, internal on-chip memory, general purpose RAM, bit addressable RAM, registered banks, and special function registers. The 8051 block diagram. This block diagram shows the basic components of the Atmel microcontroller. We are only interested in the 8051. The 8051 is made up of CPU, oscillator, bus control, 4 I/O ports, namely port 0, 1, 2, and 3, serial port, timer 0 and 1, interrupt control, 128 bytes of RAM, 4 kilobytes of ROM, and other registers. 8051 pinouts. Pins 1 to 8 is one of the 4 I/O ports. Port 1. Pin 9 is the reset pin. Pins 10 to 17 is port 3. Pins 18 and 19 are inputs to the oscillator circuit. The 8051 has an on-chip oscillator. It needs an external crystal to decide the operating frequency of the 8051. The 12 MHz, or the 11.059 MHz, crystal is often used, as it can be divided to give the exact clock rates, for most of the common UART baud rates. They are also readily available and common. The clock crystal is connected to the 8051's pin 18 and 19. And is grounded via a pair of ceramic capacitors. Pin 20 is the ground pin. Pins 21 to 28 is port 2. Pin 29 is the program store enable pin. Pin 30 is the address latch enable pin. Pin 31 is the external access pin. Pins 32 to 39 is port 0. And finally pin 40 is the VCC, or power pin. Note: P3.0 stands for port 3-bit 0. Machine cycle. The entire operation of the 8051 is synchronous, meaning it is in step with the clock signal. A single machine cycle is the minimum amount of time in which a single 8051 instruction can be executed. A machine cycle is 12 pulses of the crystal, or 6 states. Every 2 pulses is a state. Therefore one machine cycle is roughly 1 microsecond, assuming the oscillator frequency is 12 MHz. The reset pin is an input pin for master reset. This signal is high for 2 machine cycles during startup. It is low during normal operation. Input-output ports. There are 2 types of ports on the 8051. Namely serial or parallel. The 8051 has 4 input-output ports. Port 0, 1, 2, and 3. Port 0 is a dual-purpose port. It can serve as an input or output port. It also serves as the low-order address bus and also data bus for large designs with external memory. Port 0 is also an open drain port, meaning inputs of 1s will be pulled down to 0, if the port is set to 0. Port 1 is a bidirectional port with internal pull-ups. Port 2 is also a bidirectional port with internal pull-ups. Port 2 also serves as the high-order address bus for designs with external memory. Similar to ports 1 and 2, port 3 is also a bidirectional port with internal pull-ups. However, port 3 also serves the functions of various special features of the 8051, as shown in the following table. P3.0 is the RxD pin for serial receive. P3.1 is the TXD pin for serial transmit. P3.2 and P3.3 are external interrupt pins. P3.4 and P3.5 are external inputs to timers. P3.6 and P3.7 are external data memory read and write pins. The structure of the I/O ports are as shown in the diagram. Instructions that require a read, modify, or write operation, read the latch to avoid misinterpreting the voltage level, in the event the pin is heavily loaded. Instructions that inputs to a port bit, reads the pin. Dedicated bus control signals. The purpose of these signals are to control external memory expansions, for large designs. Program Store Enable is the read pin to external program memory. When the 8051 is executing code from external program memory, the Program Store Enable is activated twice each machine cycle. It is low during the fetch step of the CPU. Address Latch Enable is an output pulse for latching the low byte of the address during accesses to external memory. This is to differentiate between data and address. External access must be grounded in order to enable the device to fetch code from external program memory locations. Starting at 0000 hex up to FFFF hex. External access should be tied to VCC for internal program executions. The 8051 has 4 kilobytes of internal ROM, and also 128 bytes of internal RAM. The internal RAM consists of general-purpose storage, bit-addressable storage, register banks, and special function registers. The two key features of the 8051 memory are that the registers and input-output ports are memory-mapped and accessible like any other memory location. The other feature is that the stacks resides within the internal RAM. This diagram shows the summary of the 8051 internal RAM map. The small squares are the bit addressable memory. The number in the squares are the bit address for the specific memory location. The byte address on the left-hand side of the bigger rectangle is the address for that byte addressable memory location. Names on the other side are the names of the special function registers. General Purpose RAM. The General Purpose RAM resides in byte address 30 hex to 7F hex. They are generally used to store data. Bit addressable RAM. There is a total of 210 bit addressable locations on the 8051. 128 of these are in byte address 20 hex to 2F hex. And the rest of them are in special function registers. Register banks. There are 32 locations for register banks. By default, bank 0 is from byte address 00 hex to 07 hex. This will form R0 to R7. These however can be changed to bank 1, 2, or 3 depending on the setting in the program status word register, or in short PSW. By default also, register bank 1 is used as the top of the stack. Special function registers. There is a total of 21 special function registers in the 8051. They are used to control on-chip peripherals, view status, or outcome of the process. The program status word register. The program status word is 8 bits in length and contains the information required for proper program execution. It contains status bits called flags. PSW0 is the parity flag. PSW1 is reserved, and it is not used. PSW2 is the overflow flag. PSW3 and PSW4 are registered bank select options. PSW5 is flag 0. PSW6 is the auxiliary carry flag. And PSW7 is the carry flag. The carry flag. This flag will indicate if there is a carry out of the last bit in the accumulator, or if there is a borrow in. The auxiliary carry flag, or AC in short, will indicate if there is a carry out to bit 3 to bit 4 in accumulator A. Flag 0 is the general purpose flag where you can use in your programming. The register bank select bits will change the default register bank location to either 0, 1, 2, or 3. The overflow flag. This will indicate if there is an overflow in the accumulator A. Finally, the parity flag indicates whether there are even or odd number of ones in the accumulator A. Other special function registers are accumulator A, which is mainly used as a working register. Accumulator B, which is used together with accumulator A, for multiply and divide operations. The stack pointer contains the address of the top of the stack. By default, the stack pointer will point to byte address 07 hex. When data is being pushed to the stack, this register is incremented. And when data is being popped from the stack, it is decremented. The data pointer is used to access external code, or data memory. This is a 16-bit register. Port registers, these are memory maps for the port pins of the 8051. All port registers are bit addressable. Timer registers, these are registers to control the timer operations. We will look into this in more detail in the following chapters. Serial port registers, these are registers to control the serial operations. This will be covered in detail next semester in Microprocessor 2. Interrupt registers, these are registers to control the interrupt operations. Again, this will be covered in detail next semester, when you take Microprocessor 2. We have come to the end of today's lecture. Stay tuned for the next chapter.